So now we're going to do, I'll just write here. Network. So new topic, network address translation. Okay, everyone just says NAT. Okay. What this does is it enables many clients to share a single real, I'll put in parentheses, real IP address. Okay, so that's the whole purpose of having network address translation. And this is what's running and making it so you, like my computer or my computers at my house can all have access to the internet. All right, so let's see how this works. So here's NAT. Okay, what I need to do is I'll have the internet out here. So there's my internet cloud. Okay, I have my router, and it has a NAT module on it. Okay, so here's my router. Okay, I have a connection here to the Cox network, and where's my IP address? I don't think this is my Cox IP address, but that's okay. So my router here gets an IP address that is a real IP address. And in this case, that IP address is 60.47.112.6. Okay, so I get a real IP address from Cox. Now Cox, by the way, would rather I just had one computer on my network. And they used to, especially when I was with Verizon, they would do all these things to try to prevent me from doing NAT. But now they're nice about it, for the most part, or generally, okay? So on the other side, on my router, this is my LAN port. By the way, this will say WAN on it. I have a router over here. All right, so here's a fancy router. This yellow one, that's the WAN port that you'd connect to Cox. And then over here, this is LAN. I'm just putting them all together as one thing. If you look at the front, you guys can hardly see this, and it's terrible stuff. The internet connection has a little eye on it. Ooh, that is super glary. There's a little eye with a circle on it, and then the other ones just have a number. So WAN and LAN. So on the LAN side, this is a private subnet. Okay? And on my private subnet, I use private IP addresses. The IP addresses I can use are 192.168.x.x. I could also use other ones. 10.xxx is another range. And the other range is 172.16, and that actually has a subnet mask of 12, but your guys aren't even no one ever uses that one because it's too confusing with the 12-bit network part anyway. 192.168 is sort of the consumer one, and that's the one we'll deal with. Apple, for whatever reason, likes to use the 10, so my house really is the 10, but we're going to use this one instead. Okay, so the private subnet, again, this is picked. Normally your router is set up with one of these by default. So you're set up as 192.168. And normally it's going to be 192.168.1.1. That is the LAN port's IP address. You're going to connect your computers into this LAN port. And we'll draw a couple of computers in here. And this one might be 192.168.1 192.168. Oops. This one's going to be 0.1. Sorry. Forgot to look at my diagram I already had done. 192.168.0.2. And then my web server, for whatever reason, 192.168.0.3. And let's just say this one is 192.168.0.4. Okay. Normally your router will give these out automatically, just by default too. We'll see that after the break. That's fine. Okay. So there's our private subnet, right? So our private subnet is 192.168.0. something. There's a 1, 2, 3, 4. If I wanted to add something else, that would be 5, 6, 7. And then we're all ready to go. All right, so how does it work? I'm going to actually, since that's such a beautiful thing, and I have plenty of paper here, I'm going to switch to a new paper. Okay. So let's go down here. This is our PC. That was 192.168.0.2. I have my router here, and I'm not going to write its IP addresses, by the way. And then we're going to connect out to a web server. This server's address, this is a real IP address now, 123.7.86.28. I don't know who this is. Let's just call this web. Okay. So I want to send a message to that web server. We've already talked about how this comes out of my computer. All right. So what are the port numbers going to be on this segment? It's going to be 80 because this is web. That's good. So we'll put 123.7.86.28. Normally you put a colon in and then 80. That's the port number. Okay. That'll work, by the way, if you type into your web browser. You can put the host name of something and a colon, and then you can put the port number you want to connect on. Again, normally it's 80. Who's it from? It's from me, 192.168.0.2. Well, what's my port number? It's a random ephemeral port number. You guys remember that part? So I pick an ephemeral port number, and the one I pick is 31456. Okay, so that's my port number going to on my computer. Now here's the problem. 192.168.0.2. If I get a packet to this web server with that IP address on it, it can't get back to me because that's not a real IP address. Okay? If it's real, right, remember it's unique on the whole internet, and this isn't. I mean, there might be hundreds or thousands of computers 192.168.0.2. Okay? So what the router does with the NAT is it's going to remake the whole segment, okay, and the packet. What it does, it keeps the same two part, 123.7.86.28, port 80, okay, oops, port 80. All right, it needs that because it's got to go to the right place. Are we good with that so far? That makes sense. This is a real place on the internet, and I need to get it to that server. But the from part is where the router needs to put a real IP address on it. And what the router does is it puts its own IP address on it, which was 60.47.112.6, and then it makes up a new ephemeral port number, 52346. Okay? And then it has a table where it has 52346, and it has my IP address and the port number I was using. right? So this is my Nat table. And you guys see where it gets? You know, this came from me to this place from me. So the router records where it's from, and then it puts a new port number on it before it sends it out. You guys hopefully can see that when the stuff comes back, this thing needs to get it back to me, right? So it sends this on, and everything works just fine, okay? It gets to its destination. This is a real IP address. And now since the 60.47 is a real IP address, when it comes back, it's going to be from 120, oops. I need to put 2 in the same order. It's going to be to me, or the router, 60.47.112.6, 52346, and it's going to be from 123.7.86.28:80. All right? So this exchange here between the web server and the router is working just fine. Destination port, source port, destination port. You guys see where that's going to make it? So when the reply comes back, and it's my blue one here, 260.47.112.6, well, that's this IP address. The router will then go to its table and say, what is 52346? 52346 is to 192.168.02.31456. And so it's going to do another segment and packet. It will readdress everything. And now it's going to be to 192.168.02.31456. That's what it looked up in its table. And it's still from the web server. 123.7, blah, 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 blah. I'm not going to write all that. This is not fitting, sorry. And you'll see where the network address translation's coming along. You guys good? Or are you just falling asleep? You're just being quiet. There's my finger to say hi. Hi, everybody. It's my index finger. I'm not giving you the bird or anything. It's just saying hi. You guys have been seeing this pen all day. Green pen. So, as there's more clients and more connections here, you can see where this Nat table would get pretty big, right? All the different connections you make. You know, I talked about you might connect multiple times to a web server. Well, that means it needs multiple entries in this table. Every connection will have its own Nat table entry. It's stored in the router. Good here? Getting our traffic to and from. There's one other feature we need to worry about, and that is the NAT router also acts like a firewall. Okay? So let's put another person out here. And let's say they have something that's going, and we want them to go to our web server. Remember, this one was 192.168.0.3. That was our web server. We would like people from outside the internet to be able to get to our web server, but we don't want bad guys to be able to get into our other clients. Okay? So we like them. We don't like the other guys. Now y'all can see if someone is a bad guy and they try to make a connection to us. What's this computer? This is 192.168.0.2. They can't just type in 192.168.0.2 because routers don't even route that stuff, period. The other thing is if they're trying to hack me, and they put a routing, and let's say they put in, I don't know, port 25. They're trying to get in on in an email port, okay? The NAT needs to have an entry. Can you guys see where that would have to, it would need to have an entry in order to relay the traffic to the right place. So if anyone's trying to make an incoming connection, the NAT needs to decide where it goes. If it knows, by the way, it mostly just drops. If it doesn't know where the incoming connection needs to go, it's going to drop it. So here's what you do. If I have a web server in my private network, what port does that run on? Well-known port number for web server was, come on, we just did it on the last one, it's 80. Okay. So if I send something to port 80, I want it to go to the web server. So in the Nat table, I can actually type in my own entries. I can put port 80 and tell it to send it to 192.168.0.3 port 80, okay? So where before this happened automatically when my computer made an outgoing connection, if I want incoming connections to go to a certain place, I need to code these beforehand. So I could put an email server on here too. Let's say I want to use the same server for email. So now I have an entry that says, if something comes in with a destination port number of 25, pass that to this server. If it comes in with a port number of 80, pass that to this server. Yeah, antivirus is on your computer. This is, we'll talk about network vulnerabilities. It is quite similar. We'll worry about that in the security chapter. Okay? But this is a primitive, it's a primitive firewall. Just because it drops stuff, it means anything we haven't explicitly coded up here, it will just drop it. Okay? But it also means, for example, in the old days when you would try to host a game, like you were trying to play a game with somebody, and you wanted to host it back here, and no one from the internet can get there until you set this up. Okay? They just can't access your computer. It helps with the security, right? Because pretty much nothing coming in works. In this, you know, the normal mode is if you open a connection going out, it opens up and everything works just great. Incoming connections, though, are by default blocked. So this is called port forwarding, if I can get it to fit. It doesn't fit very well, sorry. This is port forwarding. Okay, so we want to know where does an incoming connection go? And what will happen here, just note, if we send something and it is to, I'll put it over here. So I'm up here with this person and they're sending something to the IP address of my router, 60.47.112.6, port 80, okay? So it's going to that port, then the router looks it up. So this is whoever. So whoever this is, I don't care who they are. They'll send it to the router on port 80, and then the router, did I just screw that up? Sorry, let me get it more straight. They send the packet to the router. The router then puts this IP address and this port number on it and sends it to the web server. We good here? That makes a lot of sense, doesn't it? So if I don't set it up beforehand, it just won't work. Okay, so that's NAT. If you do this port forwarding, then yeah, well, you want them to be able to access it. Like if I wanted to have people from the outside get to my web server, I have to do this.
Okay.
It doesn't, they have to know where it is too.
Yeah.
Like they have to know it's on the internet. But trust me, people are scanning the internet like crazy. I mean, I got a web server in my office, I tell you that, and I need to go check the log because I need to see if, I mean, I can see people trying to hack me. What I'm trying to see is if someone actually did hack me. That's, yeah. So yeah, once you open this up, now you have a web server that's open to the internet. But that's cool, right? Come on, that's awesome.
Well, I was saying like if it was like a private, I don't know.
Yeah, well, yeah.
Yeah, it's just something private. Well, not even necessarily just like a web server, like any server for that matter on a private network, like wouldn't.
Yeah, a business, you have a whole different, we'll talk about that stuff in the security chapter. A business, no, there's different ways of setting this up. This is just someone at their house. Like my son one of his friends has a Minecraft server sitting in his closet, and that's what they've done. You know, they set the open port or whatever port number Minecraft uses, and then they can get at it from the web, from the internet. And then my son's like, hey, I want to set up a server too, and I'm like, okay, so we set it up, but I'm not putting any port forwarding, sorry buddy. And I just put it on our network. And so, you know, he can do it from downstairs and get on the upstairs computer, but, you know, I'm not letting it out. I'm not letting outside people in. So, since it drops, you know, effectively this is like a firewall. A little bit like one. The last comment is about enterprise. NAT is very, very common, okay? You can pretty much assume that when you're on your client computer, like when you're in your office or in your cubicle, that you're going to be behind NAT. You're not going to have a real IP address. If I log on to this computer, we'll just do it right now. We're going to do staff. And let's have a look at it. Oh, look at that. Let's have a get in here to my CMD. So if I do my IP config, you'll notice here, you guys can see that, I'm 192.168.200.233. And what did I just tell you about 192.168? That's private. And so people from the outside aren't going to be able to get in here. Now, pretty much all the computers in the classrooms are this now. 2 years ago they weren't. 2 years ago they had real IP addresses. We talked about ODU. They have IP addresses like they can give out like candy. Candy? Like dirt, I don't know. What's the easiest thing to give out? But they don't, because now they want to kind of lock it down and keep it a little more secure. And so now this desktop is a private IP address. The one in my office is public, and I appreciate that, but it doesn't need to be public either.
Why would you even want it to be public?
Well, I have a web server running on mine. But, you know, if I think about the people, you know, the other people I work with, like, you know, they don't need a public IP address, but there they are. So this is a private IP address. Like I said, pretty much everybody does it. Now, if you're using what they call a small office, home office, that is a cheap router, that's going to only support, and it's hard to say, I don't know, 25 or so. We'll put heavy users. It's only going to support that many heavy users because they're going to open up tons and tons and tons of ports, right? And I note this, think about Dr. Haynes trying to do BitTorrent on his Verizon router. So I had a Verizon. This is my old days. This is in like 2000, when did I get here? 2005? So around 2005 or 2006, I had a Verizon router, and I put it in and everything ran great. And then I was talking about BitTorrent in class, and I thought I need to know how to do BitTorrent. And so I downloaded my BitTorrent client, and every time I would open BitTorrent, the router crashed. And those are fun times. You know, my wife and my family count on me to keep our internet connection going, and I find out these things when it crashes. Because I can get this thing, I go and try to do BitTorrent and it doesn't really work right. And then I'm like, oh, let me check on the internet for some troubleshooting, and then that doesn't work. And then as I walk down the stairs, it's, what happened to the internet connection? So every time I did BitTorrent, the router crashed, and it ended up, it was a NAT problem. There are too many. The problem with BitTorrent is there's so many connections in what they call a swarm. Any of you guys that do any BitTorrenting would know what a swarm is. What that is just a whole bunch of people that are sort of sharing files with each other. And you will open a connection to every single one, and it's 1,000 different connections. That was the Verizon router. Now, the routers I'm going to show you just barely, they don't have any trouble with it. Except I haven't run BitTorrent in a while. I should do it. I did something a few months ago. What did I do? No, I don't know. They're going to track me down. All right, so enterprise. Oh, that's the whole point of this. These are the ones that support thousands of users. And speaking of thousands of users, even hundreds of users, I want you all to look, when you do your project, it needs to be a business class. So when you do your, yeah, it should be business class. I would look, but everyone uses Cisco. I don't know. I'm not a Cisco stockholder anymore, so I can't be saying I'm plugging them. Everybody pretty much uses Cisco. So, you know, Netgear, what are the other ones? Linksys. Yeah, those are consumer. Oh, Belkin is a consumer too. But if you go to Cisco, you can literally get one of these. You know, it looks basically the same, 4-port router, but it'll be enterprise class designed to support hundreds of users. So that's what you need to do. So be wary of that kind of stuff.